The Permian extinction is the largest mass extinction on our planet that occurred over 251 million years ago and wiped out approximately 90% of our aquatic and 70% of life on land. The American Geophysical Union in 2013 proved that after studying and analyzing rocks from China and Russia, the Permian extinction occurred by a series of massive volcanic eruptions which covered Siberia in a thick layer of lava. These volcanic eruptions lasted for less than 1 million years. However, this caused consequences to life on Earth at that time. The volcanic eruptions around Siberia are now known as the Siberian traps. These Siberian traps release tons of carbon dioxide into the atmosphere, and in doing so, reducing the oxygen concentration. This happened as the lava went over sedimentary rocks. This baking released greenhouse gases and other chemicals into the atmosphere. One main chemical that was released was hydrogen sulfide, and compared with today is more than 2,000 times the concentration. Hydrogen sulfide is more toxic than carbon dioxide such that it kills aerobic organisms. In similarity, both hydrogen sulfide and carbon dioxide concentrations rose when oxygen concentrations fell. As it was absorbed in the Permian oceans, the concentration was potent enough to kill most oceanic plants and animals. This release of hydrogen sulfide was enough to cause ocean upwelling at the end of the Permian. This might have led for extinctions to accumulate to the high percentages. As the carbon dioxide increased into the oceans, it lowered the pH and altered the chemical balance. This process is called ocean acidification. The ocean acidification affected biogeochemical dynamics of the ocean, including calcium carbonate, organic carbon, phosphorus, and nitrogen in the oceans. In the geological record, it is shown by the decrease in accumulation and preservation of calcium carbonate in the marine sediments. The end of the Permian relayed a sudden change and disruption to the carbon cycle, high air and sea temperatures, and an increase in ocean acidification. Another issue associated with the Permian extinction is global warming. It is questioned that the global warming could have been slowed down by the process of photosynthesis. Unfortunately, this wasn't the case. Paul Wignall, a geologist at the University of Leeds, says that photosynthesis starts to shut down at about 35 degrees and plants start dying above 40 degrees. This explains why there is not much fossil record of plants at the end of the Permian. As there was no plants to perform photosynthesis, the concentration of carbon dioxide increased. With this process, it is speculated the parts of the ocean may have gone to 38 to 40 degrees Celsius. In the table, it shows some subtle but also striking similarities. This is shown in rows of temperature and ocean acidification especially. In temperature for the Permian column, it says that the temperatures are between 10 to 30 degrees higher than they are today, whereas in today's column they are only slightly increasing. For ocean acidification in today's column, it is shown as slowly emerging. Reconstructing the climates of the Earth would be quite interesting, as it would be a snapshot of what it was like at that time. And with technology, the accuracy would be much than what it was previously. However, this increasing evidence of mass extinctions is a reminder for global carbon emissions and their reduction. Disregarding the extinction for a minute, if you think about the life on Earth at that time, it would have been amazing and intriguing to see the wildlife. For example, the emergence of bony and cartilaginous fish in our oceans. There is such a hidden beauty in regards to prehistoric life and wonder. What if? Also, reconstructing the climates would give you detailed plans and evidence as to whether or not they did scope the landscape. The Permian was a catastrophic event that caused nearly all life on land and in the ocean to be extinct. These conditions were at an extreme that it was crazy to see the result. From the table, some similarities and differences are evident. For example, hydrogen sulfide, with that extreme volcanic activity, we won't be able to reach those high concentrations. However, temperature and ocean acidification is striking. Technically, we are already in a mass extinction, and it is sad to find out that humans are the main culprits to wiping out entire species. As we put out more carbon dioxide, the temperature will slowly continue to increase, and the rate of acidification will increase as well, without further intervention.